So here we have what we call the Pythagorean Theorem. And so what is the Pythagorean Theorem used for? It is used to find missing side lengths. Okay. And so we have different parts of a triangle for Pythagorean Theorem. And in order for us to use Pythagorean Theorem, it has to come from a right triangle. And we know it's a right triangle if it has one 90-degree angle. And so we have what we call the legs, right? So the legs of my right triangle. And so what we label A and B doesn't really matter. What does matter is what we call C. C is going to represent your hypotenuse, your longest side of the triangle, right? And it's always going to be across your 90-degree angle. How we use Pythagorean Theorem is what most of you guys are familiar with, which is what we call A squared plus B squared equals C squared. That is a Pythagorean Theorem, and we use that, or a variation of that, to find any missing side. So here we use it to find, well, we don't really, so if we were looking for side C, right? So C, then using Pythagorean Theorem, we can manipulate that by simply taking the square roots on both sides. And if I were to take the square root on both sides, then we end up with A squared plus B squared, and then the square root of that would be equal to C. And for A, it's almost the same thing with one extra step. This time we're going to have to subtract the opposite. Now, here's what I mean by it doesn't matter whether we call it A or B, because if I were to solve for B, we end up with the same thing. C squared minus A squared, right? And remember, these are interchangeable. So that could have been A, and which means that would have been B, and vice versa. So here are the only two that we need to really worry about, right? So one of them, if we're looking for the hypotenuse, we add it together. If we're looking for either leg, then we subtract it from C and then take the square root. So let's take a look at some problems, right? So the very first thing is labeling the diagram. And again, what you label A and B doesn't matter. What matters is your C, right? And so let's call that A and B. And so once again, since we're looking for C, then I'm going to use A squared plus B squared and take the square root of that. So here, I'm going to substitute in what I know. So I know A is 8, B is 13, and we do a little math. So A squared is 64, 13 squared is 169. Add those together. So 64 and 169 is 233, which is a prime number. And so here, that's what we're going to leave it at. So the square root of 233. So look at the second one. We approach it the same way. The very first thing that we're going to do is label. Now, what we label the sides don't matter. What we do care about is what we label C. So that's A, that's B. So in this case, well, to make it easier, that's B, that's A. And so in this case, we're looking for A, which is telling me I'm going to use the square root of C squared minus B squared. And I'm going to substitute in what I know. So C is 9, B is 7. And so we simplify. So 9 squared is 81. 7 squared is 49. And so we do a little math. So 81 minus 49 gives us the square root of 32. And so here we can leave it as is. If they're asking us to simplify or give it to them in lowest terms, then we have to simplify. So 32, break it down, that's 8 times 4. We can further break down this 8 to 2 and 4, and we can pause here because we have a set of, or we have a pair of 4s, right? So that set of 4 brings 1 4 outside and the 2 stays inside. So here, this side measures 4 square roots of